Today I'd like to demo a little bit about how reactive values work in Volt. Reactive values are kind of the underlying concept that lets us automatically propagate changes to our DOM. Basically, reactive value is actually a class, and basically we can initialize it with anything, and what we get back is a wrapped value of that class. So here I wrapped the value 1, and you can see when inspect is called on it in the console, we put the @ sign in front of it to show you that it's reactive. I can get the value by saying .cur, which gives me the current value. I can also reassign the value by saying .cur equals. So it's your basic wrapper class. What's interesting though is that any methods that you call on the wrapper class get passed down to the underlying class. So here I can say b equals a plus 5, and plus is a method call in Ruby, so we get back 7. What makes this interesting is that the reactive value isn't actually running the computation right away. It's running it when the inspect is called, or any method that sort of makes it concrete is called. So it's interesting, you can see b is still 7, but if I was to change a to 10, and then we look at b, we have 15 now. And so you can kind of see how what this actually lets us do is build up a computation graph. And so reactive values handle a whole bunch of different situations. So say we redefine b to be another reactive value that's equal to 12, for example. So now we have 10 and 12. We can add them. Again, we can say c equals a plus b, and it works on both sides. And if we change either one, we get the right value. Now, where this actually becomes useful is if we want to know when things change. So what we can do is we can take a reactive value, we have a, and we can listen for events. So the change event is a pretty common one. And we can say .on and pass the string changed for that event, and then we'll print something out. So if I say a cur equals 2, it says, it lets us know that it changed. Calling this .cur actually triggers a changed event, and we could trigger events manually on the reactive value. We could say we could trigger change manually. What's interesting though is if we've got b here, c, which is a plus b. We can listen on C, for example, for changes. And the reactive values are smart enough to know that when one of the parents change, it actually will affect the value of C, so we'll trigger that event on C as well, so it'll propagate down. So again, if I change A, you can see that it told me A changed and C changed. But here I can also change B, and C changed as well because C depends on A and B. So you can see this is kind of the underlying concept and how we actually do event propagation in Volt. Talk a little bit about the models as well. Go ahead and start over here. When you're working with models in Volt, what you're actually getting is like when you say page or store or one of those, you're actually getting a model class wrapped in a reactive value class. And so where this is nice is that the models let you kind of attach any data like you would a hash using the underscore. So any method prefixed with the underscore will return another model. So here we're returning, it's a nil model, but we're returning because it hasn't been defined. But then if we set it to something, or to a value, and we ask for it again, we get this value out. So this gives us an easy way to store things. And the model class has all of these things built in to know how to intelligently propagate these changes. So when I change something, if I had another property and I was listening on that one, and let's say I was listening on something as well. So now if I change something again, you'll notice it only propagated it to the value that matters. And it's intelligent, so if I had a method that say used both of these, it would know when the right one to propagate to was. And so this is how the bindings work. They actually listen for the changes. They subscribe to the changes, and then when they're removed, they remove the changes. So the one thing I didn't mention is if you're listening to a change event, what you actually get back when you call on is you get back a listener, and a listener has basically the only method you need to know about is remove. So now if any value in A changes, I'm going to get a value in A changed until I remove it, and so now it won't tell me about it. And so a lot of this you don't have to know directly. It's all kind of handled under the hood. But what this gives you is a reactive programming API that's very straightforward. You can basically just use it like you normally would. A few cases being, if a few of the things you have to watch out for is just that these reactive values are always truthy, even if you're wrapping. So if I did, if I wrap nil, I'm going to get back, so these are method calls in Ruby too. So that works, returning a reactive value. But I guess if you're checking, if you're doing it in an if statement, it's going to return true all the time. So you just want to, when you're running it through an if statement, you're going to want to check, you're going to want to pull out the current value and check it with that. You can also do true, actually that got changed. So yeah, you're going to just want to do the current value. Trying to think, there's a few other things. If you do have where you want to, a couple of the other gotchas, a lot of times you'll do something like A is nil, B is 5, and then in your code you'll do A or B. So with Ruby, the or and the and are not method calls. So just to make that easier, we extend object, and you can do a dot or b like that, and it's a method call. And what's interesting is if A was reactive, it'll return a reactive value. So that if A changes, so say I make A 20 now, I should have set that to a variable, but it would update for you. So it's nice because the way I think of it is the reactive values are sort of, I hate to use the word, but they're sort of toxic. They not necessarily in a bad way, but whenever you do a reactive value and some other value interacting, you typically get back a reactive value. And so that's nice because whenever the reactive value changes, if you were getting back the non-reactive value in a reactive value, you now get back the original reactive value in a reactive value, if that makes sense. Trying to think if there's anything else. That's basically it for reactive values. They're fairly straightforward, and they give you a lot of power, especially thanks to the fact that almost everything in Ruby is a method call. You can write things like comparators. So if B is a reactive value, say these are equal. So we can say C equals A equals B, and we're getting true. But then if we change B to 21, C is now false. And so this is how Vault implements its bindings, is actually you just pass in a comparator, the result of a comparator, and it listens on it. So it makes for very clean code under the hood, especially since everything's fairly unified. So that's the general overview of reactive values and how they work. I'm going to be doing some more tutorials. Please let me know if you have any questions. Thanks.